Hi there, my name is Abba Ndomo, and this is my Lab 1 report exploring an object's motion at constant velocity. So, the experiment outline can essentially be broken out into four major constituents, where firstly, I'm going to capture the motion of an object moving at constant speed without changing its direction on any given flat surface, as illustrated in this video. Then, using Tracker software and Microsoft Excel, I'm going to extract the object's position and corresponding times, which I will then use to plot a position versus time curve. Then I'm going to construct a predicted position versus time plot using GlowScript. And then finally, I'm going to compare the predicted position versus time plot to the observed position versus time plot to analyze the discrepancies between the two. Moving on to the key assumptions of this experiment. The first key assumption is that the object moves at constant speed throughout the experiment. Another assumption that kind of follows directly from this is that we assume that the direction of the mass does not change and that a zero net force acts on the object. Fourth, we assume that the object lies on a completely flat surface with no inclination, which therefore leads to zero acceleration due to gravity, and finally that the motion is completely one-dimensional. Moving on to the track analysis, some key points to consider about the setup is that the origin is placed at the approximate center of mass of the object, as illustrated in the image on the right. Secondly, the object's motion is from right to left, as illustrated in the previous slide, which therefore implies that its displacement values are going to be negative. Subsequently, the magnitude of the velocity, which is the speed, and displacement, which is the position, will be used instead for the rest of this experiment. More on the tracker analysis, the instantaneous speed and position values are then imported from tracker onto an Excel spreadsheet. Then the object's position, which is highlighted in blue, is plotted against time. On the same graph, the object's instantaneous speed in white is also plotted against time, however with a fitted regression line. Now on the GlowScript computational model, using the equation for the regression line I obtained in the previous slide, I calculated the initial speed as 0.1906 meters per second. This is because, according to Newton's second law of motion, if there exists a zero net force acting on the object, then it must have maintained its initial speed throughout. On GlowScript, I plotted a predicted position versus time curve using a time step of magnitude 0.01 and the derived initial speed value and plotted the graph on the upper right of this presentation. Now, to compare both of our models, I plotted the predicted position versus time curve on the same graph as the observed position versus time curve. According to our diagram, we observe that the predicted curve in purple deviates from the observed curve as time progresses. Secondly, we also observe that the predicted position curve is always greater than the observed position versus time curve. This implies that the object actually decelerates and does not maintain its constant speed. Something else that we observe is that the position curve appears to flatten towards the end, which further supports the hypothesis that the object does not maintain its constant speed. So, what if the x-axis was inverted? In this case, I believe that inverting the axes would not have any effect because my model only considers the magnitudes of the position and velocity variables. However, if this weren't the case, then inverting the axes would result in positive displacement and velocity values instead of negative values because of the right to left motion of my object and the positioning of my Cartesian axes. So, what are the forces that give rise to the zero net force in this case? I think it is not possible to determine these forces because our model neglects the existence of resistive forces acting on the object. As a result, after the initial change in momentum that initiates the motion, to maintain constant speed, we must assume that no forces act on the object. Otherwise, the possible forces influencing the motion of the object would be air resistance and friction, which would yield a net negative force that would cause the object to decelerate. Thank you so much for listening to my presentation. I hope you have a good rest of your day.